Okay, remember our discussion on this last example where when we talked about we need to square both entire sides? Keep that in mind for example number 8. This equation has two radicals, and I do wish that it was legal to come along here and square terms, like say squared, squared, and then square that maybe even, okay? And then you'd get rid of both of those radicals at once, but that's not legal, okay? On an equation that has radicals in two different terms, you've got to isolate one of the radicals, square both sides to get rid of it, okay? Then isolate the other radical, get rid of it by squaring both sides, okay? So on this example on 68, I'm going to choose one of these radicals to get on a side by itself. I think it's easiest probably just to leave that square root of d plus 4 on the left-hand side, and we can move this other radical, the square root of 6 plus 2d, by adding it to the other side. So now what we have is the square root of d plus 4 equals, I think it might look a little bit prettier. You could write that as -1 plus the square root of 6 plus 2d, but I think I'm going to write the positive term first. Square root of 6 plus 2d is what we should have. Let me wipe that whole thing out. There we go. Square root of 6 plus 2d, and then the -1. Okay, now we're ready to get rid of this radical on the left-hand side by squaring both sides. We got to square the entire side over here. Don't forget that. So now, when we square the square root of d plus 4, that just leaves us with d plus 4 on the left-hand side. Got rid of that radical. On the right-hand side, again, because we have two terms, we need to expand this out and FOIL. So we're going to have the square root of 6 plus 2d minus 1 times the square root of 6 plus 2d minus 1. Now we're going to have to FOIL that out on the right-hand side. Let's bring down the d plus 4, and then we'll FOIL out on the right-hand side. When we take first times first, the square root of 6 plus 2d times the square root of 6 plus 2d, that is just 6 plus 2d. No radical. Same reason, y'all kind of off the side over here, that the square root of 17 times the square root of 17 as an example is just 17, right? Same thing there, okay? So there's first times first. Now when I multiply outer times outer, that's going to give me a -1 times the square root of 6 plus 2d. You don't have to write the -1 there, but I'm going to. Okay, now when I do inner times inner, that's another -1 times the square root of 6 plus 2d. I like to line up my like radicals is the reason I wrote that way. And then last times last, -1 times -1 is a +1. Let's clean some stuff up. Okay? All right. So bring down the d plus 4. Okay, I can go ahead and say that 6 with the 1 over here is 7. Bring down the plus 2d. And then when we combine these like radicals, I've got -1 and -1 of those is going to combine to give me -2 of those square root of 6 plus 2d. True? Okay, now start the process over again. We're going to isolate the radical. We're going to isolate the square root of 6 plus 2d. Then we're going to square both sides to get rid of it. So subtract 7 from both sides, and let's subtract 2d from both sides. All right, so we have -1d, or just -d, minus 3 equals negative 2 square root of 6 plus 2d. Hey, you know, all of those terms are negative. I think, you don't have to, but I think it'd just be a little bit easier for us just to think about going ahead and multiplying both sides by negative 1. Now, the reason I want to do that is, well, first of all, I can. It's legal. And second of all, that's going to give me a nicer equation in d plus 3 equals now a positive 2 times the square root of 6 plus 2d. I got rid of those negatives because I don't need that negativity in my life. I just got rid of it. That's a joke. Okay, so now we could divide both sides by 2. I don't really like that because that's going to create some fractions over there. All right? I'm not a huge fan of that. So you don't have to isolate just the radical as long as you have the term with the radical isolated. We are going to deal with that too when we square both sides now. Again, go through the process of squaring both sides. So over there on the left-hand side, we have d plus 3 quantity squared. Expand that out in FOIL. Okay, I'll do that in the next step. Now on the right-hand side, when we square a product, and that is 2 times the square root of 6 plus 2d, you can, when you have a product, you can just square each factor. So 2 squared is 4. That's going to be multiplied by the square of the square root of 6 plus 2d. That's just 6 plus 2d, no radical. That's why we squared both sides, is to get rid of the radical. Now, we have kind of a mess, but at least we have an equation that's free from radicals. So let's do our algebra moves and get that solved. FOIL out the left-hand side. First outer inner last. That's what I did there. Combining the 3D and the 3D to give me 60. Here, I'm going to run the 4 through. So we'll have 24 plus 8d. Now get everything on one side equals 0 because I see my quadratic term over there. So I'm going to subtract 8d from both sides and also subtract 24 from both sides. Okay, so we have d squared minus 2d. And then minus 15, that's 9 minus 24. And then equals 0. All right, let's see. Quadratic, is that thing factorable? Can I find two numbers that multiply to give me negative 15, but combine to give me negative 2? I think so. How about a d minus 5 and a d plus 3. Okay? All right, I'm going to recopy that. I'm having to scroll, so I'm going to move all that up to the top of my paper here. Oh, whoops, I'm going the wrong way. There we go. I'm going to move all that back up here, at least where I can see what's going on. Okay? Remember, we had d minus 5 times d plus 3 equals 0. We've got a factor times a factor equals 0. Set each factor equal to 0. That's our zero product property, and solve for d. So we have a potential solution of positive 5 and another potential solution of negative 3. Now, what we're going to do is check those both back into that original equation. Okay? Let's see. I'll check in purple, I think. Let me check the 5 first. This will look like the square root of 5 plus 4 minus the square root of 6 plus 2 times 5 is going to be 10 equals a negative 1. So let's see, square root of 9 minus square root of 16 equals negative 1. Let's see, is 3 minus 4 equal to negative 1? Sure is. That thing checks. D equals 5 is in my solution set. Okay, let me check the negative 3. Okay, so I've got the square root of negative 3 plus 4, which is the square root of 1, which is 1. Okay, then I've got minus the square root of 6 plus 2 times the D value is a negative 6. Is that equal to negative 1? I don't know. Square root of negative 3 plus 4 is square root of 1, which is 1, minus the square root of 0. That's going to give me positive 1, not negative 1. That doesn't check. Okay? So there's another extraneous solution. And I don't want you thinking that, hey, negative answers aren't going to work because we haven't seen an example where they do work. That's false. Negative answers can check. You have to check them to see. So our only solution set is 5. Actually, the only element in our solution set is 5, is how I should say that.